Okay, 8.10, volume with the disk method, revolving around other axes. Volume of a revolved solid is the volume from A to B of pi times the radius squared with respect to x. Find the volume of the solid formed by revolving the bounded region around the given line. Set up the integral, then evaluate using a calculator. Okay, example 1, y equals 3 minus x squared, y equals 2. Revolve around the line, y equals 2. Yeah, I'm going to sketch a picture, but we could do this without a picture. So picture is useful for some people who like pictures, not for others. Okay, y equals 3 minus x squared is a parabola. Y-intercept is 3. Y equals 2 is lower. It's a horizontal line. Okay, so we're taking the shaded region, which is this one, revolving it around the line y equals 2. Now, y equals 2 is way up here. So this is getting revolved around here, and it's going to make some kind of solid going in that direction. Okay, so that's what we're trying to do here. So let's go ahead and set it up because it's very similar to what we were doing to do. Volume equals, since I'm rotating or revolving, there's going to be a pi. Whether you put it inside or outside is up to you. I'm going to put it outside for now. Okay. Y equals 2 is horizontal. It's parallel to the x-axis. We're going to do this with respect to x, so we need to figure out the x values that are bound in this region. I need this x value and this x value. So I'm going to go ahead and set the two equations equal to each other. So what are the two equations? 3 minus x squared equals 2. Okay, let's go ahead and solve. So I'm going to move the x squared to the right and the 2 to the left. So is that 1 equals x squared? So x equals plus or minus 1, which looks reasonable. This could be negative 1 and this could be 1. So I'm going to use those for my boundary. Okay, for the radius of my solid, it's going to be from here to here. So from here to here. I'm going to go ahead and keep the value positive, although remember, because I'm squaring it, the order actually does not matter, so you can go ahead and swap them. The same is true in your homework. If you have this swapped order, but you're squaring it, it doesn't make a difference. Okay, the farther function is the parabola, so that's going to be the 3 minus x squared. And then the closer function is this line. The line is y equals 2, so it's going to be minus 2. And then because it's a radius and I'm squaring it, and then this was with respect to x, I'm going to put in my calculator. So you can put this directly in your calculator. If it is helpful, you can simplify it first. It's up to you. If it's a calculator active problem, you do as much as you need to do to make it helpful. And don't forget about the pi on the outside. So when I approximate this, I get 3.3510-ish. They should be cubic units, but if they don't ask me for units, I'm not going to give them. Okay, let's try example 2. Okay, example 2. X equals 5 minus y squared, x equals 1. Revolve around the line x equals 1. Okay, I am going to sketch a picture, but I'm going to start it without the picture because some of you, the picture is harder than not the picture. Okay, I'm revolving around the line x equals 1. X equals 1 is a vertical line. Since it's a vertical line, it's parallel to the y-axis. So this is already telling me that this is going to be with respect to y. That's my first hint. Okay, let me find the y boundaries. I haven't graphed it, so I'm going to try to do it without the graph. Okay, I'm trying to solve for y. They gave me two equations, so let me set them equal to each other. Y squared. So I get y equals plus or minus 2. Okay, let's set it up, even though we have no idea what we're doing. Okay, since I'm revolving it, they're going to make circles. So they're circles, they're going to be pi r squared. I'm going to go ahead and put the pi on the outside just to get out of the way. You can put it on the inside, it makes no difference. Okay, my boundaries are y equals negative 2 to positive 2. The radius is the distance from the upper boundary to the lower boundary. Now again, it doesn't actually matter which one goes first, and these are my two functions. Because I'm squaring it, it doesn't matter. But because it occasionally matters when we're doing the area bounded, I'm going to find which one's higher and do it in the correct order. But it does not matter, and you can swap them. Okay, to figure out which one's higher, between negative 2 and 2, I'm going to plug in 0. When y is 0, this is always 1. When y is 0 here, this is 5. So this is the higher function. So I'm going to put that first, although again, it does not matter. Okay, so I'm going to have 5 minus y squared, and I'm going to subtract the other function, which is 1 dy. Oh, I forgot to square it. Pi r squared. Okay, does that look correct? Okay, let me go ahead and simplify it, only because I'm putting it, because for me it's easier than to type it in my calculator. Okay, I'm going to go ahead and put it in my calculator, and then I am going to sketch it after for people who like to sketch the picture. Okay, I got about 107.2330 cubic units. Okay, let me go ahead and sketch it for visual people. Okay, here's my axes. X equals 5 minus y squared is a sideways parabola. The x-intercept is 5, so it's going to go something like this. X equals 1 is vertical. So this is my shaded region. I'm revolving it around x equals 1, so this is actually my revolution line. Okay, so we found that y is negative 2 to 2, negative 2 to 2. That looks correct. And then from the axis, the farther function was the 5 minus y squared, and then the closer function was the 1. And I would have ended up with the same equation and the same answer. So if the picture is helpful to you, use the picture. If the picture doesn't help you, you can do it without. Okay, last example. Y equals 2 to the x minus 3, y equals negative 2, x equals 3. We're going to revolve it around y equals negative 2. Okay, first thing I'm thinking is y equals negative 2 is a horizontal line, so I'm going to do this with respect to x. Okay, am I going to sketch? I'm going to sketch it because I am a visual learner. Okay, so y equals 2 to the x minus 3 is some kind of increasing function. And the y-intercept of that is actually 0, negative 2. Okay, y equals negative 2 is a horizontal line, like that. X equals 3 is somewhere around here. So my bounded region is going to look something like this. We're revolving around y equals negative 2, so we're going to go with respect to x. So I'm doing this with respect to x. Okay, so the volume is, since I'm rotating, it's pi r squared. Okay, because I graphed it, I can see the x boundaries are from 0 to 3. Okay. If I had not graphed it, I would set those two functions equal to each other. It's y and y, so I'm setting the y's equal to each other. So 2 to the x equals 1. What does x have to be for x to equal 1? Or 2 to the x to equal 1, x equals 0. This is from 0, and then they told me I'm going till x equals 3, so it's from 0 to 3. Okay, the radius is the farther y minus the lower y. The farther y is the 2 to the x minus 3. Minus the closer y is the negative 2. And then because this is a radius, I'm going to square it, dx. Okay, now again, this and this can be swapped because when you square them, it's not going to have any effect on your result. I'm going to simplify it just for the sake of less typing in my calculator. Minus 3 minus negative 2 is negative 3 plus 2, negative 1 squared dx. And then in my calculator, I get about 88.7411 cubic units.